Are you ready? Yeah. Okay. We're going to do something a little bit different today. That's why everyone's got their computers, but we're just going to go over a few new things for like 5-10 minutes, and then we're going to actually write some code together. And we're going to be writing kind of a little bit more complicated algorithms. So like what we've been doing so far has been kind of trying to get the structure of like classes and methods and variables and all that stuff. So now we're going to try to write some stuff that's you have to use a little bit more logic and cleverness, and it's actually kind of like the fun part of programming. So it's kind of like getting past all the administrative stuff that you have to do and getting to the stuff that actually requires you to think and be clever. And that's kind of what is fun and cool. So let's get into the quick lesson first. So we're going to introduce this new operation called modulo, or mod for short. And it's probably new to you, but it's actually probably just a new name for something that you already know. And basically, it's the remainder. So if you remember when you learned long division in middle school, or whenever you learn long division, when you divide a number by another number and it doesn't divide perfectly, you get a remainder, right? So that's all that modulo is. So this is the symbol. It's percentage sign in Java. And here's an example. So we've got 7 mod 3. So basically, can anyone take a guess as to what this would evaluate to? 1. Yeah, nice. So it's pretty simple. Does everyone see how Matt did that? So you do 7 divided by 3 basically, and you get 2 with the remainder of 1, right? Just like division in math, not too complicated. So what would this be then? 10 mod 2. 0, right? 0, all right. Pretty straightforward. And then what would this be? This is kind of, yeah, 2. Exactly. So, yeah. Pretty simple, but it's really useful for different things, like in graphics when you want to wrap something around the screen, or maybe when you want to see if a number is divisible by a different number. For instance, if you were trying to decide if a number was even, you could do that number mod 2, and if the value is 0, then you know it's even. If the value is 1, then you know it's odd. So that's just a new tool real quick, pretty simple. You guys seem to get that pretty quick, so that's good. All right, here's something else. So it's pretty often in computer science that you want to increase the value of a variable or decrease the value of a variable by 1. And it's going to become even more often when we start learning about for loops and arrays and while loops. So basically, the way we've done this so far is, okay, here we are declaring a new variable I of type int with the initial value 5. And here we are increasing the value of I by 1. So this is how we've done it so far. We said I gets I plus 1. Now it's pretty simple, and I'm sure you guys understand that at this point, and that's good. But Java basically made a shortcut. So this is what they decided. So now we have a new variable y type int, initial value 5, and this is now the shortcut for incrementing by 1. So it's plus plus. So y plus plus essentially does the same thing as I gets I plus 1 down here. So we've given y, increased its value by 1. So now y has a value of 6. Or this is supposed to say y. Must have copied and pasted. And similarly, you can do y minus minus, and that probably, as you guess, decreases the value by 1. So now y is going to have a value of 5. So again, this is just a syntax thing, but you're going to start seeing that when we start doing for loops, so I wanted to introduce you guys to it really quickly. But does anyone have a question there about this at all? And, oh yeah. No, unfortunately not. That would be pretty cool. No, there is a different shortcut for adding 2. It's y plus equal 2. Plus equal sign, and then the number 2 would be y gets y plus 2. And then you can do that for anything else, but there's a special shortcut for just adding 1 because it's such a common thing that you want to do. But I wouldn't worry about it too much, because if you forget it, you can always just do this. But it's pretty easy to remember. If you guys have ever heard of the computer language C++, that's like a computer science pun, because it's like the next version of C. And it's obviously hilarious. So yeah, so that's the idea. Just a shortcut, pretty simple. Use it or don't, but it's there if you want it. Okay, so now we're going to get going on something a little bit more substantial and actually really, really useful and important, called for loops. So it's pretty common that you're going to want to be able to repeat an instruction that you're writing a certain number of times. And up until now, we haven't really been able to do that. You would have to write the instruction out and then tailor it every single time, which is obviously a pain and obviously would produce lots of bugs when you messed up. So now we've got this nice tool called for loops. It's got tons of uses. When we start getting into different data structures and arrays and lists and stuff like that, it's going to be basically what makes those things work. So it's important to understand for loops. And here's an example. This is what it looks like in Java. So let's go through it piece by piece here. So we've got new keyword for, pretty simple, just like in English. And then we've got these three conditions in here, and they are encompassed by these parentheses. So we're going to go over what each of these conditions are on the next slide, but just know that this is kind of the conditions for your for loop, which decide how long it's going to run for and how it's going to work. And then down here we've got our block of code, which is bookended by these curly braces. And this is the code that's going to be repeated, which is going to be executed in your loop. So for every cycle of your loop, this code will be executed one time. So it doesn't have to be one line. It can be 100 lines or 1,000,000 lines or whatever you want. But anything in between these two curly braces is going to be executed every cycle of your loop one time. So that's the idea. So let's look at the conditions of the for loop. So we've got this first part here. There's three parts, and they're separated by a semicolon. So the first part here is a declaration and definition of a counter variable. In this case, we have one, they're typically going to be ints, and this one's called I, which is pretty common to call your counter variable in your for loop, but obviously you can call it anything you want. And so you want to give it an initial value that makes sense. So if you want to count from 0 to 100, then give it an initial value of 0. If you want to count from -2 to 20 or whatever, then give it an initial value of -2. But this is where you decide basically where your loop's going to start. And okay, so that's our first condition. And then don't forget your semicolon to separate the second condition, which is a Boolean condition, very similar to the Boolean condition of an if statement. So here we've got I less than 10. So basically what happens here is on every single cycle of the for loop, what happens first is we check and see if our counter variable is less than 10. And if that's true, then they go ahead and execute the next cycle of the for loop. If it's false, then the for loop stops and the rest of your code below it is executed. So this decides kind of the number of times that your for loop is going to execute. So in this instance, we've got I less than 10, and since we're starting out at 0, and since this third condition is counting by 1, it's going to execute 10 times from 0 to 9, basically. Okay, yeah, and then I alluded to this in that previous explanation, but this is our third condition, and this is to update our counter variable. So here, if you remember from a couple slides ago, we were using our new syntax here, I++. So we're saying on every iteration of this loop, I increases by 1. So this is a kind of a complicated way to put a simple thing, because all this is really doing is saying execute this piece of code 10 times. And the way we know that is because we've got a counter variable, which is initially 0, and it goes up 1 every single cycle, and it stops when it gets to be 10. So we know that's going to execute 10 times. Can everyone see that? So does anyone know what this whole loop? Yeah. Right. So basically what will happen is, so we get here, we have our new variable, which is 0, and then we check and see if 0 is less than 10, and because it is, we execute this. So we print out 0, right? Because that's the value of our counter variable. Then we go back up, we add 1 to our counter. We check and see if that's less than 10, so now it'll be 1. 1 is less than 10, that's fine. Go ahead and execute again. So we print out 1, and then we go back up here and we add 2, or add 1 rather, and now our counter variable is 2. And since 2 is less than 10, we execute again, we print out 2, and so on and so forth until we get to this being 8, right? And this adds 1 to that, and that's 9. And then we've got 9 is less than 10, that's fine, so we execute again. We print out 9, and then we go up here, we give it 1 more, and then I becomes 10, and 10 less than 10. Okay, that's false, right? That's no longer true. So then the for loop stops, this doesn't execute, and we continue down here. Yep. Right, exactly. So if you wanted to go to 10 and have 10 execute as well, then you'd have less than or equal to there. So yeah, that's totally fine. Does everyone see that? Yeah. The first line? Yeah, right. So that exactly, good point. This just happens on the initialization of the for loop, so it only happens once. So this is just right when the for loop starts, you initialize your variable, give it an initial value, and then that line doesn't happen again. But this is just kind of like a formality. You'll get really used to writing the syntax and not actually even thinking about how it actually works because it becomes really intuitive. But when you start out, obviously, you have to think about it. So that's the idea. So does everyone kind of see how that works? All right. So that's it for our lesson part of it. Now we're going to go into a little bit of coding. So if you guys want to boot up your computers, that'll be cool. Sorry, I think I sent you a text, but maybe you didn't get it. Huh? I thought I sent you a text.
Oh, I don't know.
Oh, it's all right though. Can you actually work at Paul's table, Joe?
Yeah.
And then you guys can kind of just work together. Yeah. Okay. Let's do it. 1 sec. Right here. How long is that, Joe? All right. Sorry about that, but I think we're cool now. All right. So has everyone got Eclipse up? So we're going to kind of write together, as I said. So we're going to accomplish a few things, and I'll go through what we're going to try to do in the beginning of every single one. And then if you ever encounter a problem or anything, you can just raise your hand and ask me real quick, and we'll get that sorted out, just so we all aren't lost or anything like that. So first step was we're going to create a new project, new Java project. You can call it whatever you want. I'm going to call mine math project, I guess, because we're going to do mostly math things. So yeah, get that sorted out. And then once you have your new project, we're going to give it a class real quick to write into. And I'm going to call my class math. All right, does everyone have a new class? No, not yet? All right. All right, we ready now? All right. So we're going to start out simple and get a little bit harder. So our first, well, first I guess let's get the the boilerplate of the class done. So this is where we put our instance variables. But in this instance, actually, we're not going to have any instance variables because this is going to be mostly just writing methods. So we're not going to have any instance variables for this class. So that's totally fine. As I said when we were going over objects initially, we can have objects model physical things, and then we can have them model ideas or intangible things and processes. So although up to this point we've been modeling basically physical things, this is going to be our first modeling of intangible processes, basically. So that's fine. And for that reason, we're not having any instance variables in this instance. But we're going to give it a quick constructor. So I'm not going to give it any parameters because I don't think we need any. And then all my constructor is going to do, and you can do this too if you want, is just print out new math object created. So this is just to let us know we've created a new math object successfully when we eventually do that in the main method. But that's our constructor. So pretty simple there. Give it a little bit of a comment too. Also, I'm going to write comments. You guys don't necessarily have to, but this will probably just help you see what's going on a little bit better. Can everyone see this all right? It's pretty small. Let me mess with this real quick. Oh, actually, I kind of need that. Interesting. Yeah, I guess if you can't see, we've got to just push closer because we have room up here. Okay, so is everyone basically up to this point? All right. So our first assignment is to write a method which takes in a double and then returns true or false based on whether or not that double is negative. So this is how, can anyone think about how we're going to do this? First, let's just get our declaration set up. So we're going to have a new method. It's public. It's going to return a Boolean, either true or false. And I'm going to call mine is negative. And one parameter is a double number. So does anyone have an idea about how to attack this? So the idea is we're going to decide whether or not this parameter, this double, which in my case is named num, is negative or whether it's positive. Yep. Right, okay. So we're going to use an if statement, which has a condition of whether or not that parameter is less than 0, right? So this is how that's going to look. If num less than 0, return true, right? Because if it's less than 0, it's negative, so we'll return true. And then else, return false. Okay. Does everyone see how that's working? So we're using the parameter that's coming in, and we're asking, is the parameter less than 0? If so, return true. In essence, saying it is a negative number, and else return false. In essence, saying it's a positive number or 0. Okay. So that's good. And basically when you're programming, it's a pretty good idea to test what you're writing basically like as soon as you can. Otherwise you end up writing a bunch of stuff and you get a lot of bugs and it gets really confusing and daunting to go back to stuff you've written a long time ago and try to debug it. So in order to comply to what I just said, we're going to create a new class real quick. Oh. God. Yeah, if you get annoyed by that, you can just do Alt-Shift-N, and then you can just have it locked in. Okay. So I'm going to call mine main, because it's just basically going to have a main method, which does some method calls for us. So static void main. Also, you can do the you can click the box when you're creating the class that does this stuff for you. But I remember it pretty well, so I can just do it. So that's our main method in our main class. And what we're going to do here is create a new instance of our math class. So what we just wrote. So it's going to look like this. Math. So new object type math. I'm just going to call mine lowercase math, just to be simple. Gets a new instance of the math class. And you remember our constructor didn't have any parameters, so it's just an open and closed parenthesis. And there we have it. So we've got a new object instance of type math called math. Does everyone see that so far? Inside our main method? Cool. So now, in order to test what we just wrote, we're going to call that method on our math class. So we're going to do, I'm going to do a little bit of printing first just to make it more readable. The number -4 is negative. And then this will say math dot is negative, -4. Print that out real quick. Okay, so we're printing out the number -4 is negative, and then we're printing out the return value of the method that we just wrote. So it's either going to be true or false. And because -4 is actually negative, we're hoping that's going to be false, right? I mean true, rather. Because otherwise we would have a bug. So let's just run that real quick. Okay. Get down there. Okay. So this is good. So down here, we see that up when we created our new instance of the math class, the constructor was called and it printed out new math object created. Perfect, just like our constructor told it to do. And then this line right here executed, and we printed out the number -4 is negative, and then we printed out the return value of this method call to is negative with -4 as a parameter, and that returned true, which is good, right? Because -4 is in fact negative. So that all checks out, and then let's just do, I won't do it as nice, but one more just to check it thoroughly. And let's just do is -0. So now we're hoping this returns false, right? Did everyone see that? And it does. Perfect. Okay. So that's our first method of our math class, written and then tested. And thankfully, there's no bugs, which is nice. Unless, yeah, Joe.
I can't get it to run.
Okay. One sec. Sorry. Okay. Oh, okay. It's because you're trying to run that other project. It's fine. So just right-click on that math project real quick. And then just do run as, and then Java application. So the one below it, actually. And then it's because you were trying to run your old project. Section does not contain. Oh. Public static void mainstream main. Oh, okay. So your classes were going. Oh, okay. Yeah, interesting. Can you see this real quick? So for some reason these aren't going in your source folder. I don't know why. Let's move them in there. Okay. Okay. Hopefully this works. Okay, there you go. All right, yeah, it was just weird. when you're creating a new class, it has to like go in the source folder. So sometimes it doesn't, and then you just have to drag it in basically.
Okay.
It can be kind of annoying, but that's looking good then. Yeah. All right. One sec. Let's click out of that. Oh yeah, you have the same problem. Okay, I don't know why that's happening. I'll look into it. Interesting. Your Windows must have restarted you for some reason. All right, we're gonna move on, but you guys can jump in because you have all the stuff going. That's kind of annoying. Windows is annoying sometimes. Oh yeah, that's gonna. Okay. Okay. Yeah. So you just forgot the else part of that. I'll show you. So yeah, all you have to do is say else and then return true. You can see it right there. Yeah.
I've asked you this before.
Yeah.
So you did math and then that lowercase math.
Yeah.
I remember you said you could change that lowercase.
Yeah,
math
yeah, yeah.
anything you want. Can you explain like why you did that again?
Yeah. Okay. So basically, that's all that is declaring a variable. So like you remember when you do int space x or something like that.
Okay.
So math, the lowercase math is just your variable name. So it's like what you decide. So you could make it whatever you wanted, like just m or math object or something. But the uppercase math is the type.
Okay.
So that has to be that because that's the name of the class, right?
Okay, I got you.
So unless you wanted to call your class something else, then it has to be that class name
Okay. Awesome.
in order for the type to be correct. But yeah, that's the idea. Okay, is everyone else caught up except for that restart problem we got going on over there? Yeah, I guess just let me know when that, or I guess just you can jump back in when that's done. Just follow along for now. Okay, cool. So that was our first kind of warm-up method. And we're gonna keep upping the ante here. So our next method is gonna be an absolute value method. So if you guys remember from math, taking the absolute value of something is basically making it positive. So if you have if taking the absolute value of -1 gives it a value of 1, or taking the absolute value of 1 gives it a value of 1 as well because it's not negative. Does everyone know what absolute value is all about? Okay, so we're going to make that happen now. So we're going to write a method which takes in an integer and then returns an integer, and the integer that it takes in as a parameter, it's going to return the absolute value of that. So the way we're going to do this is, let's just get it set up first. So public, because we're writing a method, our return type is int. I'm going to call mine just absolute value to be clear. And then parameter int num, again, is fine. And okay, so now we have to take this parameter num, which is an int, and we have to return the absolute value of this. So does anyone have any ideas about how we can do this? This is a little bit more tricky, right?
If the num is like less than 0,
Yeah.
return that number as a negative.
Yeah, okay, yeah, you're right on. So you're gonna test and see if that num is negative, and if it is right, then you return that number times -1, right? So timesing a number by -1, basically just, if it's negative, it becomes positive, if it's positive, it becomes negative. So first, like Matt was saying, we're gonna check and see if this num is negative. And we could do num less than 0, but because we already have a method that does that for us, we might as well just call it here. So we're kind of building on top of our own work. So to call a method in a method of the class that you are writing into, you don't actually need to do an instance dot method name, you just have to say the method name because you're inside that class. So here we are, we're calling oh, I didn't mean is double, I meant is negative, right? With this num parameter. So if it's negative, what are we going to do? We're going to say num gets num times -1, right? And then down here, we're just going to return num. So does everyone see that? So we're saying if this parameter is negative, times it by -1, and otherwise you're not doing anything, and then you just return the number. So that should give us an absolute value of our parameter, right? Does everyone see that? But again, let's test it real quick. So we save it, go back into our main class, and let's just keep going here. So system.println math dot absolute value of -25 or whatever you want to test it. And then we can get rid of some of these just so we don't get confused during the testing process. So let's run that. And nice. So you can see down here in our console where I printed out our absolute value method successfully returned the absolute value of -25, which is of course 25. So is everyone, I'll go back to the other class real quick so you can see the method. Are people getting that? Getting that all right? Yeah. Yeah. So all we're doing in the main is we're just printing out the return value of the method call to absolute value. So if everyone remembers, calling a method is just using the variable and then that you want to call a method on, then dot, and then the method name with any parameters of that method. So has everyone got that so far? Is it run and executes all right? How are you guys going over there with the restart? Getting it going? All right, cool. Yeah. All right, so okay. So basically you're trying to refer to a variable that we don't have yet, num. So all we need to do is give this a parameter, right? So if you can see over in the other one, there's a parameter just like you did up here, except for it's going to be an int actually. So nice. Okay, perfect. So then I think you should be cool if you run that. Nice work. Okay. All right, did everyone get that one so far? All right, let's keep stepping it up. So now, let's see. Now we're gonna do, we're gonna write a method which returns a true or false based on whether or not a parameter is even. Okay? So let's just get that set up real quick. So method public, where it's going to return true or false, so it's going to return a Boolean. I'm going to call this is even because that makes sense to me. And then this is going to be an int, and num's fine. You can just keep using that if it makes sense to you. And okay, so that's the declaration of our method. So how are we going to do this? How are we going to figure out whether or not this parameter is even?
Is it just counting up by 2?
Yeah, that would just count. That would just count up by 2. Nice try. What are you thinking, Joe? Okay, close. So it's actually something we went over in the beginning of this class. Does anyone remember? the modulo, right? So yeah, so yeah, okay, you got the idea. So let's just get it all out there. So we've got if num our parameter, mod, so that's what the percent sign that Matt's talking about, 2. So if that equals 0, right? So if number mod 2 equals 0, then what is our num going to be? Even or odd? Even, right? Because that's essentially saying if you divide this number by 2, there's no remainder, so then it must be even, right? Because that's basically the definition of an even number. So that's cool. So then what are we going to do within this if statement then? We're going to return true. Perfect. And then else, return false. Okay. Yep.
What's the percentage?
Yeah, okay, so that's the modulo operation, which sounds complicated, but it's really not. It's just basically, it calculates the remainder. So basically, it's saying, it's like dividing by 2, and then it's taking the remainder. So, yeah, the remainder for dividing by 2. So if you did like 5 mod 2, or like 5% sign, so if it's like 5% sign 2, then the answer would be 1. Because so it divides 5 by 2, which is 2, with the remainder of 1. And then if it was 6 mod 2, it would be 0.
So it means divide and get the remainder.
Right, yeah, exactly. So, okay. So does everyone have the is even method going pretty good? Okay, so let's just test that real quick. Just to be sure. You never know if you make a typo or something, it's pretty easy. The PRINTLN. Oh. Math. So now we're calling the is even method. I'm going to give it a parameter of 6. So hopefully that returns true. I'm going to get this out of here so it doesn't confuse me. Make that a little bit neater. Okay. So let's run this real quick. So hopefully we're getting return true, and we do, which is really nice. And then let's try like -5 or something. And that returns false. So I'm feeling pretty confident that this is working. So is everyone getting there? Is even working pretty well? Testing it out. I'll give you guys a second. How are you guys doing over there recouping from that? Okay. Okay, I'll switch back to the math class real quick. Yeah. Should be at least, hopefully. Okay. So everyone got the is even going? Nice. Okay. Now let's step it up a notch from that. So now we're going to write a method similar to our is even method in structure, but it's going to decide whether or not a parameter is a prime number. Okay? So this is a little bit more involved. So let's just get our declaration out there. So public, because it's a method, it's just going to be like is even, so we're going to return a boolean if it's true if it's prime, and a false if it's not prime. And I'm going to call mine is prime just to kind of be consistent with my method names. And taking integer, that's a number again. And okay, so that's our declaration. So let me see one sec. Does anyone have a good idea about how this is going to work? This is a little bit more involved, right? Basically, what's the essence of this? How are we going to decide whether or not a number is prime? Yeah, so what is the definition of a prime number? It's Matt's got it. It can only be divided by itself and 1, right? So it's a number. I think the proper definition it's a number, an integer greater than 1, which is only divisible by itself and 1. So how are we going to test if a number is prime? Like, this is a little bit more confusing, right? It's not one simple check like it was with even or negative. So how are we going to do this? Any ideas? The hint is that we're going to have to start using these for loops that we talked about. So we're going to have to start doing multiple checks. Anyone got any ideas? This is like kind of a classic computer science problem, actually. And the simplest way to do it is simply to check if every single number less than a given number that you're testing is a divisor for that number. So basically, if you wanted to check if, I don't know, 7 was prime, you would see if, okay, can you divide 7 by 2? Can you divide 7 by 3? Can you divide 7 by 4? Can you divide 7 by 5? Can you divide 7 by 6? And because the answer to all those is no, then you know that 7 is prime, right? So that's the idea. Now we need to get that into code. So we have to take the idea from our design and actually code it up in Java. So this is a little bit more involved. So I'm just going to start writing, and then we'll explain as we go and try to tweak it to make it good. So I'm going to start out by just declaring a variable that's going to hold our return value, just to make this a little bit simpler. So I'm just going to call it is prime. That might be a little confusing because that's our method name. So is prime number, I guess, just to make it different. And it's going to start out being true. Okay? So we're going to assume it's a prime number until we find out otherwise, just like we kind of did in our head there. So we assume it's a prime number, and we check every number that's less than it. And if any of those numbers does divide that number, then we automatically realize that we no longer assume it to be a prime number. So that's exactly how we're going to do it in code. So now is time for the almighty for loop, which we just went over. So this is how it's going to look in practice. So for, keyword for, and now we've got our 3 conditions. So if we remember correctly, our first condition is declaring a counter variable, which is typically an int. I'm going to call mine I, just because I usually do. And now, what value do we want to start at here? This is our first decision we need to make in our for loop. Which is the first number that we're going to check? 2, right? Because we're not going to divide by 0, and we're not going to divide by 1, because we automatically know that 1 is going to divide any number, right? So we're going to start at 2, just like Matt said. And then, okay. So what's going to be our max value that we're going to go to? What number are we going to count up to?
Num.
Yeah, num, exactly. So our condition here is going to be I less than num. And then over here, we're just going to go up by 1. So this is where the I++ comes in. So you could do I gets I plus 1. But a nice shortcut is just I++, just like we went over. So that's our for loop. That's the skeleton of it. So now we need to write the code inside of that we want to repeat every single cycle. So what do we want to check every single time? Well, we want to check if our num is divisible by our counter value, basically. Does everyone see that? All right, can anyone think about how we check to see if something is divisible by something? Basically just did that in our isEven method, right? Yeah. Yeah, right. So you check the remainder. You check the modulo function. So we're going to do an if statement. If num, our parameter, modulo I, our counter, right? So if that equals 0, just like up here with our isEven method. So if number can be perfectly divided by I, right? So our counter value. What does that mean, basically? That means that number is not prime. Exactly. So it means that it can be divided by something and therefore it's not a prime number. So we're going to say is prime number gets false, right? So now we're resetting our Boolean to be false because we've realized that this number can be divided by something that isn't 1 or itself, so it's not prime. Sorry. So then all we have to do down here is return is prime number after our whole for loop is done, and voila, we solved a pretty complicated problem, right? Now we're able to determine whether or not any integer is a prime number or not, which is pretty cool, and it has a lot of applications. It's got applications in all sorts of security softwares and all sorts of other algorithms in games or other pieces of software. So that's a pretty complicated problem solved in 6 lines, or whatever you want to call it, 7 lines. So that's kind of like the power of programming right there. Now we can discern whether or not any integer is a prime number, which is really hard to do in your head and really easy to do in the computer. So let's test it real quick. So we're going to go back to our main class. We're going to say math.isPrime, and I don't know, let's start it out with an easy one, 7. Because we all know that 7 is in fact prime, right? So hopefully this returns true, otherwise we've got a bug. And there it is, nice, true. So let's give it something a little more difficult. Let's give it, I don't know, 1300 or something. So 1300 is not a prime because it's divisible by 2 and probably a bunch of other things. So let's check that real quick. False. Nice. So that's good. So there it is. We're not positive if it's bug-free, but it looks good. So maybe I'll try 3, which should be a prime. True? Okay, nice. Is everyone getting kind of similar results with this one? Do you guys need me to go back to the math class? I'll go back there real quick just in case. All right. So that's cool. Now let's extend upon this. So let's write a method now that takes in a parameter, which is an integer, and it returns the largest prime number that is less than that parameter. So let's do something like this. Let's do public. It's going to return an int, and I'm going to call mine biggest prime, I guess. And it takes in an int, which is going to be our max num. And all right, so that's our declaration. Now, how are we going to do this? We've already done basically the hard part, right? Now we've got the capability to decide whether or not a number is prime. But now we've got to kind of build on top of that capability. So how are we going to do that? Well, basically it's going to go back to for loops. So we're just going to do it just the way you would do it in your head. So if you had to do this problem in your head, you'd probably look at the number that you needed to find the biggest prime beneath and just simply go up, up, and up, and up, and up until you found the biggest prime number that was under that number. So that's exactly what we're going to do. And we're going to start out with the lowest prime number here, 2, because that's what we know is the lowest prime number, and we're just going to build on top of that, right? So we've got our variable biggest, initial value 2, and then now we need to start working through all the possible candidates above that. So we're going to have another for loop. So initialize a counter variable. Now what number do we want to start at here? What number do we want to start checking? The top one. Well, we could do it that way. Yeah, actually, that would probably be a better way to do it. So we could do max num. Okay, and we'll do, so we're going to have to structure our for loop a little bit differently, but Paul's got a really good idea. So then we want to do, so we're basically going to count backwards from the max number. So basically we need to say I greater than 2. And then I minus minus, right? So we're counting down by 1. So that's good. That's our for loop structure. So now we just need to start checking, right? Well, we already basically have the horsepower to check whether or not a number is prime number up here in our isPrime method. So all we got to do is see if this num that we're checking, which is our counter value, or I guess we got to do like this, call our isPrime method with I as the parameter. So this is going to return whether a true if I is prime and a false if I is not prime. And so if that's the case, we're going to return I. So if I is prime, then return it. Right? Does everyone see that? Now, that should work. We're going to need a catch-all return value down here because it's not going to be happy. Return biggest. We can just get rid of biggest, actually. Return 2. Okay. Perfect. Does everyone have that so far? Now we've got to check it. Okay. System dot out. Math. Dot biggest prime. And let's find the biggest prime less than or equal to 100. Does that sound good? Let's see. 97. Right? So that's pretty cool. Now we just did something basically instantaneously that probably would have taken us a little bit to figure out on our own. And then we can do like maybe 1,000. So what's that going to be? 997. Wonder if that's pretty crazy. Then let's try like 10,000. 9973. Okay, so we got a pretty cool thing that we've written. And actually, this is going to be our first instance of something that is not completely scalable, right? Like if I put in, 10, what is this? If I put in a million or something, it's probably going to take a long time, or at least a noticeable amount of time to compute. So, I was actually really fast. Let's give it another 0. Okay, still really fast. One more 0. Okay, so now you can see it's taking computational time. It's computing, it's checking all these numbers. And this is, so now it just finally reached an answer, and you can see that the bigger your max number is, the longer it's going to take. And this is where getting more efficient with your coding is actually going to come into play. So you can make little optimizations like, if you remember in our isPrime method, we checked every single number less than a number. But if you really think about it, you don't actually need to check all those numbers. You just need to check the numbers up to that number divided by 2, right? So that would be an example of an optimization you can make to speed up your program. But usually that's not going to be something you have to worry about. So I just kind of wanted to show you guys an instance of a problem that isn't so simple that a computer can just do it instantly. And this is actually a problem that the computing world at large is facing, because really, really big prime numbers are really useful for cryptology and making your networks more secure. So basically, they're kind of running out of really, really big prime numbers. And it's harder and harder to find big primes. And even with like gigantic supercomputers, we can't compute massive prime numbers really quickly. So doing optimizations in this situation is actually kind of helpful. But that's the idea. So that was writing some more interesting algorithms that required us to think, which is like my favorite part of computer science. And I think once you guys get like the basics down, it becomes your favorite part too, because it's where you have to be clever and where you actually have to kind of, it's like it becomes more like a puzzle than just getting frustrated at a computer for not for making a typo or something like that. But that's the idea. So you guys did a really good job here, and we're going to actually kind of extend upon this type of thinking in lab this week. So good job, guys, and I'll see you Wednesday.